If you haven't turned in your slope-intercept form packet, be sure you do that. I'll be giving those back to you, but I would definitely hold on to them because you can definitely use them to help you on the upcoming quizzes. So today we're looking at 4.1. We're going to look at proportional relationships and slope. So two quantities are proportional if they vary and have a constant ratio or unit rate. So the graph of a proportional relationship is a straight line through the origin. So those are the two things that have to happen if it's a proportional relationship. It has to go through the origin. Remember, that's the point 0, 0, right in the middle of the graph. And it has to be a straight line. So relationships that have straight line graphs are called linear relationships. Proportional relationships can be represented using tables, graphs, words, or equations. So a linear relationship is proportional when the ratio of y to x is a constant m. So 0, 0 doesn't really count, but -3 divided by -1 is 3. 3 divided by 1 is 3, and 6 divided by 2 is also 3. So that's constant. M is our slope, right? So M is always y divided by x, or y equals mx, where M is the unit rate and it does not equal 0. So we can find the slope if it goes through the point 0, 0 by just taking y divided by x. It's a little bit trickier if it doesn't start at 0, though, like we found. All right, so an equation such as y equals 3x is called a linear equation. A linear equation is an equation with a graph that is a straight line. Notice that this equation also contains more than one variable, right? We have a y and an x. Guys, please stop talking. The solution of a linear equation consists of two numbers, one for each variable that makes the equation true. So that's why we've done a lot of work with tables, right? When x equals something, then y is something else. So a rate of change is a rate that describes how one quantity changes in relation to another. Remember, we are seeing how y changed in relation to x. In a linear relationship, the rate of change between any two quantities is the same or constant. This is called the constant rate of change. All right, so the time to download songs is shown in the table. As the number of songs increases by 2, the time in minutes increases by 1. So the unit rate is 2 songs per minute. This is 176. So the unit rate is that constant rate of change. For every minute, it goes up 2 songs. All right. So in proportional relationships, the unit rate is the slope of the line. Slope is the rate of change between any 2 points on the line. You can use the points 1, 2, and 2, 4 to find the slope. So remember when we were looking at our formulas, y2 minus y1 divided by x2 minus x1. That's how we were finding the slope. That's what they're doing here. The second y value minus the first y value, 4 minus 2, and the second x value minus the first x value, 2 minus 1. Remember that slope formula? We've done this, so hopefully this is helpful. 4 minus 2 is 2. 2 minus 1 is 1. So you can find the slope from the graph as well, not just from the table. All right, so here's our first example. Hopefully these will be easy peasy. The graph shows the amount of money Ava saved over several weeks. Find and interpret the slope, then find the unit rate and compare it to the slope. So here they're kind of showing us our slope. They took the y changes, the second minus the first, so 30 minus 15, right? Y2 minus Y1. And then they took the second x value, which was 2. So x2 minus x1, 2 minus 1, to get $15, right? 30 minus 15 is 15. $15 per 1 week. That gave us the unit rate. All right, so the constant rate of change is $15 per week. So the slope of the line is 15 over 1 or 15. Remember, it goes up 15 over 1. This means that Ava saved $15 every week. All of these proportional relationships are starting at 0, 0. If it's proportional, it starts at 0, 0. So that's a little bit different than the lines we've been looking at, right? Ours had different y-intercepts. All of these y-intercepts are 0, which is why we just have it in the form y equals mx, because b is 0. So find the unit rate and compare it to the slope. Ava saved $15 every week. So the unit rate is $15 per week, which is also the slope of the line. All right. So try this on page 178. The graph shows the relationship between feet and inches. What is the slope? And then find the unit rate, which is the slope. So part A and part B are pretty much finding the same thing. Find the slope of this line. Should be quick and easy. What do you think? What is it going up for everyone? Get out your workbooks. Something helpful. All right. What did you guys say for the slope? It's going up 12 over 1. So up 12 inches. Hopefully you said A. So 12 inches per feet, which is equal to 12 over 1, which is the slope. Pretty straightforward. Maybe even a little more elementary than we have been working with. So hopefully that makes this section easy. Here is the second one. Graph the equation, make a table of values to find the distance. All right. So for 0 hours, 12 times 0 is 0. For 1 hour, 12 times 1 is 12. For 2, 12 times 2 is 24. We've done this before, right? So if we are graphing these points, we're putting a point at 0, 0. It's proportional, so there has to be a point there. At 1, 12. So here's 1. Here's 12. And at 2, 24. Here's 2. We got to go all the way up to 24. Draw a line through the point. So grab a straight edge, piece of paper, your planner, something. And draw a line through it. Usually, our line contains arrows in both directions, but since it's proportional, it's starting at 0, 0 and just going upward. Find and interpret the slope. So it's going up 12 for every 1. Notice we have to look at the values on the x-axis because we might think this was 2 if we didn't look, right? Because it jumps over 2 boxes. But we have to watch these things. So we didn't say 1, 2, 3, 4, and then divide by 2 to get 2. We actually went up by 3. So we've got to pay very close attention to the values along our axes, right? Our rate at which the y's and the x's are going up. So it's really up 12 over 1. So that's how they got 12 over 1. This means that cyclists can ride 12 miles per hour because our slope is the same as our unit rate with proportional relationships. Try this check on page 180 before we move on to example 3. If you need to, think about your equation. So if you need to make a little table to help you find points on your line, or you could do this like you were drawing a line, your y-intercept is 0. Why is it? Oh, these are in hundreds. So here is 200. Here is 400. Here is 600. So at 0, y is at 0. At 1, y is at 200. Or in this case, at 2, because each one is 100. At 2, we're at 400. So we've got to skip 2 up to here, right? So we're going up 200 every time. Which of the following is the correct interpretation of the slope? The slope of the line is 1 over 100. Is it going up 1 for every 100 seconds? No. Is it going up 100 for every 1 second? No, that would be right there. It's not going up 1 for every 200 seconds. It's going up 200 beats for every 1 second. So this is D. All right, example 3. An online music store charges $3.75. So we're kind of adding in some decimals here for purchasing 3 songs. Assume the cost y in dollars is proportional to the number of songs. That means it starts at 0, 0. There's no added fee. So graph this relationship on the coordinate plane, then find and interpret the slope. So they already did this division for us. 375 divided by 3 is $1.25 per song. So the unit rate is $1.25 per song. Remember, per essentially means divided by. That's why they put this fraction bar here. So $3.75 divided by 3 is that $1.25. So we would end up with $2.50 here, and then $1.25 more than that would put us at $5, I believe. So then we can graph it. The point 1, 125. So we got to go between 1 and 1.5 here on the y-axis. Do you see that right here? At 2, we've got to go up to 2.5. At 3, we have to go up to 375. So that is between 3.5 and 4 on the y-axis. And at 4, we're going up to $5. And that should make a straight line. What is the unit rate? How much is it per 1 song? $1.25. That means that's the slope. It goes up $1.25 for every 1. Again, we have to be careful by looking at our labels there. What is the constant rate of change? Same thing, $1.25 per song. That's our slope. So the slope of the line is $1.25 over 1, or 1.25. This means that the cost is $1.25 per song. All right, so try that check on page 182. It's important that you know how to graph. You need to make a little table to help you. We know that 10 miles every 2 hours. So if we were looking for every 1 hour, we would say 10 divided by 2. Right? If we were looking for 3 hours, we would say 3 times whatever our unit rate is. Try that out, plot those, and interpret the slope. This is page 182. All right, so hopefully you said 10 divided by 2 is 5. 3 times 5 is 15. These are going up by 5s for every 1. So that should tell us that our slope is 5 for every 1, right? We can plot our points here. It's going up 5, but notice each one of these lines up is 5. So we're not actually counting up 5 and going over 1. We're really just going up 1 and over 1 each time. Oh, my line got a little wonky. All right, so our slope is 5 over 1, or 5 miles per hour. That is the same as our unit rate. All right, so we can use tables, graphs, words, equations to represent and compare proportional relationships. Remember, because our y-intercept is 0, these are in the form y equals mx, where m represents the slope or unit rate, right? These have to do with proportional relationships only. So we can find the constant ratio by saying y divided by x, or finding the point when x equals 1, the y value is our unit rate, or our slope. All right, so in words, the cost y is directly proportional to the number of breakfasts. So we say for every breakfast, it costs $2, right? 2 times 2, 3 times 2, 4 times 2. Notice the change is 2 divided by 1, so y divided by x is equal to 2 divided by 1. That gives us our m. Right? If you were solving this, y equals mx, you could divide both sides by x to find m. Right? So y over x equals m. Remember how we solve equations? So the distance y in miles that can be covered by a rabbit in x hours can be represented with this equation. Find the speed of the rabbit. The speed is another name for rate, right? This is the grizzly bear speed, but we need to figure out the speed of the rabbit. What's the slope here? What's the unit rate? M, 35. So which animal is faster? Find the speed of the grizzly bear. This is the point, 30 divided by 1 or 30 divided by 1. So the speed of the grizzly bear is 30 miles per hour. So which is faster, 35 or 30? 35, of course. So the rabbit is faster. So you can find, we could use the change in y divided by the change in x, right? To get 30 over 1. Or you could simply say the constant ratio is distance divided by time to get 30 over 1. Or they use the point, right? On the graph, the y coordinate is 30 when x equals 1. The point 130 represents the unit rate, which is 30 miles per hour. And then all we had to do was compare the unit rate, which we already did. We said the rabbit is faster. All right. So try this check on page 184. Figuring out relationships and heartbeats. So here's a dog. And here is the cat. Which has the faster heart rate? Remember, we're just looking at M here. So the dog is 1.5 beats per second. So we could say BPS. And the cat, looking here, this is the 1, 2. So it's going up 2 for every 1. So 2 beats per second. So who's faster? The cat has a faster heart rate anyway. Interesting. All right, I think this is our last example here. The cost Y for computer repairs at Computer Access for X hours is shown in the table. Macro Repair charges $23.50 per hour for computer repairs. Assume that the cost is proportional to the number of hours. So cost per hour, 50 divided by 2 is 25. So each one of these hours it goes up, it's going up 25. Here's the unit cost. So the cost is $25 per hour. We're kind of going rather quickly because we've done a lot of this, right? We've looked at tables. We've looked at our change and our rates. From the problem, we know that it charges $25. And the rate of computer access at Macro was $23.50. So Macro Repair, wait. Oh, we just found the cost of computer access. The cost of Macro Repair was that $23.50 per hour. Sorry. So since $23.50 is less than 25, Macro Repair has the cheaper cost of repair. All right, these next few problems should be quick and easy. Oh, we've got one more check. So we're comparing $7.95 per hour with whatever it is here. So we can say $14.50 divided by 2, $7.25. So this is her current job. This is her new job. Which pays more, new or current? New, right? That's all. So go ahead and look these last few minutes at 1, 2, 3, and 4. You're essentially finding the slope, graphing and the slope. graphing and the slope. And here you're comparing panel A to panel B. Try those. I know you only have about 5 minutes or so, but these should be pretty quick.